Let's name some aldehydes, ketones, and alcohols now. What I'd like you to do is look at this name, and you'll notice that they have not separated out the butane like I normally do. So what I'd like you to do first is look at that last thing, butane, and draw a carbon skeleton for butane. I'll stop the video and do that now. Good. Now that you've done that, what you want to do is notice that we have trichloro. That means we have 3 chlorines to place on that butane chain. And your butane chain should have been 4 carbons long. Okay, we got to put one of these chlorines on 1, and then we have to put on carbon number 2. On carbon number 1, and then on carbon 2 and 2 again. So let's look at the actual structure and see what that's going to look like. Now this won't be in a skeleton, but it will be something that you can recognize. What I want you to notice about this molecule is that first of all, we put a chlorine here on the first carbon, and this is carbon 1 because this is the end that has a chlorine closest to it. And then our other 2 carbons, to make a total of 3, are sitting on carbon number 1, 2. And so we have 3 chlorines altogether, which is why we call it trichloro. And they're sitting on carbons 1, 2 for this guy, and 2 again for this guy. Now let's go down and look at a structure and see if we can get a name out of it. This guy, we have to draw a carbon chain for. Would you do that now and put in a double bond and look at how many carbons you have? Stop the video and do that now. Good. For this one, you have a total of 3 carbons because that's all there are. 1, 2, 3. And that would normally be called propane, except it's got a double bond here, which makes it a propene, which is what we use as an ending, P-R-O-P-E-N-E. So we've got a chlorine here, and you'll notice that the double bond is going to trump the chlorine so far as determining who is going to be carbon number 1. So in our name, we're going to use the base length of the chain as 3. The double bond is on carbon number 1 of the propene, but it can only be on carbon number 1, because if it's here, this guy's going to be number 1, and if that double bond were moved over here, this guy would be number 1. So we don't need to say what the number is, we just call it a propene in this case. And then the chlorine is going to be sitting on carbon number 3. So the double bond trumps the chlorine to determine who's going to be number 1. So we're going to call this 3-chloro propene, and we're done. Now here we don't have any double bonds, but we have a lot of chlorines, and we're going to name these chlorines in our name, and we'll see how that actually comes out. Would you draw a carbon chain now to indicate, just a carbon skeleton, to indicate how long this guy is, and make it easier for you to see where your chlorines are. Stop the video and do that now. As we look at this now, you should have had 1 chlorine on the first carbon, the second carbon would have a chlorine, and then the third, 4th carbon would also have a chlorine. So this is not a chlorine. No, this is a methane. So we have chlorines on 1 and 2, and we have a methane on carbon 4 of a 1, 2, 3, 4, 5 carbon chain. Now, as we know, the halocarbons, the chlorine is a halocarbon. All the guys in column 17 on the periodic chart. So the chlorine is going to trump the methane so far as determining who's going to be carbon 1. So this guy is carbon 1. So we have chlorines on 1 and 2. That makes 1,2-dichloro. And then carbon number 1, 2, 3, 4. 4-methyl, sorry, 4-methyl. And this is going to be a pentane. So that's the naming for this guy. And now as we go down and look at another one, let's see, that one was 28B, and the book actually agrees with me on that. Let's go down and look at some stuff on another page and see what we can see over there. Okay, let's look at this 39A. By the way, this is out of a textbook that we're not using. And what we want to look at here is a 2-carbon compound. You're going to draw a 2-carbon skeleton with a double bond O on the end and a hydrogen. And you should be able to pretty much figure out this one without any help from me. But draw the carbon chain now and turn off the video while you're doing that, and then come back. Okay, you should have drawn a 2-carbon chain, and this guy is going to have the carbonyl group, the C double bond to an O, and then a hydrogen on it. And so this is going to be an aldehyde. And aldehydes have an ending AL. This is a 2-carbon compound, so this is just straight ethanal, ethanal. Now let's look at this guy. Aha! We have an OH group on there. That tells us something, doesn't it? Draw a 2-carbon chain, put an OH on the end, and then after you've stopped the video, and then come back and let's name it. So if you have that drawn now, we have 2 carbons. That's going to be an ethane, but the OH on it makes it an ethanol, ethanol. See, what we do with the hydroxide group and the aldehyde group and the ketone groups is we take off the E ending, and then we add the for alcohols, the OL. For aldehydes, like we had back here, we take off the E from the ending, so we take the E off of ethane, and remember this is ethanal, ethanal, where this is ethanol. And then if we have a ketone, we're going to have an ethanone, but I don't have an example right here to show you on this one. That's the end of this video.